Good morning. The bell ringer today is, you can see this little graphic of a 3-pathway maze. It's considered a corn maze. Let's read the little excerpt. Church group sells pumpkins every year to raise money for their children, the children of their town. This year's crop produced very small pumpkins. The group decided to construct a corn maze in a field and charge customers to walk through the maze. Customers can walk only forward, and if the customers end up at an exit with pumpkins, they win a pumpkin. The group asked students to advise it on various possibilities of a customer getting a pumpkin. So let's analyze that. Let's see, what does it say? All right, what methods can help you visualize situations like this one that have multi-stage events with a variety of pathways and those with compound events? All right, so how are the stages of an event shown on a tree diagram? How do you read a tree diagram? Well, let's look into it. So we're going to make a tree diagram to show the group the possible paths customers might take, entering the maze on the upper, middle, and lower path, proceeding to an exit with or without a pumpkin. So this is the first pathway outside of the entrance to the corn maze. So you have 3 different pathways. So if we randomly select a pathway, there's a 1/3 likelihood we would choose one of the 3 paths. 1 of 3, hence that's the name 1 divided by 3. And the top pathway, if you take the upper path, goes, if you take the left section, 1/2 of them going on the top upper path would take no pumpkins, and the one going south or the right path would get pumpkins. The middle path, also 1/3 coming off the front, just goes directly to pumpkins. 1/3 of the people that walk into the thing are going to get a pumpkin, period. At least if they take the middle path. Last path, kind of like the top one, except it's opposite. Top half of the path goes to the pumpkin, the other half doesn't go to pumpkin. Notice that this is separated into 1/6 and 1/3 here. Well, it may behoove you to know, to find the total probability of something, how is this tree diagram different from others you've worked with before? Or most tree diagrams work from top down and not from left to right. That's typically the way you do it. The weights on each branch are a bit different, aren't they? Yes. Notice they're not all the same weight. This is 1/3, this is 1/2, this is 1/2. How can you have all this in this one line? I think you might find it interesting to find out that the sum of these 2 numbers and the sum of these numbers and the sum of these numbers are all 1. Going across, that's just, that's something completely different. All right. Let's go back to this. If we want to know the probability of getting no pumpkin, we would just multiply through. So 1/3, 1/2 is 1/6, or 1/3 and 1/2 is 1/6. We add those 2 together. The probability of getting no pumpkin is 2/6. 1/6 plus 1/6 is 2/6, or 1/3. Getting pumpkin, we'd add the 3 that gets a pumpkin. 1/6 plus 1/6 plus 1/3. Change this 1/3 to 2/3 or 2/6. 1 plus 2 plus 1 is 4/6 or 2/3. So 1/3 and 2/3 is 1/3. We know it's right. All right. So let's look at this tree diagram. It shows all the possible sandwiches if you go into a little delicatessen. 2 selections of bread, 3 selections of meat, and 4 selections of cheese. Now, how do we know the total number of possibilities? We'll look at that here in a second. So, choice of white bread and all the options of that sandwich. All right. Choice of ham, turkey, or beef, or choice of meat, I'm sorry. And then the choice of cheese. Notice that it's broke up. Each one has its own tree. Ham has all 4, turkey has all 4, and beef has all 4. All right. Let's move on. How about with the wheat side? Same thing. It's exactly the same way. Cheese is separated into 4 different groups. Let's assume, for the case of this lesson, we make all the possible sandwich combos that you can use using 1 choice from each column of ingredients in the table. 1 bread, 1 meat, 1 cheese. We'll place all these different sandwiches in unmarked sack on the counter. Given this information, can we answer the following questions? What is the probability that someone will select a sandwich with white bread? Well, how many different types of breads are there? There's two. If you select one of the two, you're going to get a possibility of one of two. Or you can look at it this way. Half of the sandwiches are made on white bread. Total possible, 24. 12 out of 24 is 50%. Okay? What's the probability of select a sandwich with American cheese? Well, since bread or meat is not an option, we'll go straight through and just look at the different types of cheese there are. Well, there's only 4 types of cheese. I would assume that the answer is one of 4. One of the 4 cheeses is being used. That makes the probability 1 of 4. When you look at it through the lens of a tree diagram, you have 6 of 24 because each one of the 4 cheeses comes off of either wheat or white. So we're going to have American cheese, and American cheese only comes off of one of each of the tree diagram of the meats. That's 1/3 on the wheat and 1/3 on the white, and that means that we have 1/3 plus 1/3. I'm sorry, that's not true. I apologize. Let me go back and look at this diagram real quick. So, American, right? 1/3, 1/3, 1/3, but we got the wheat side. How about the white side? 1/3, 1/3, 1/3. Is that right? No, it's 1/3 times 1/4, which is what? 1/12. So it's 1/12 times 6. Right? Times 3, which is 24, or times 4. So 12 over 24, 50% of them are going to have white bread. We already said that. American cheese, 6 of 24. Probability to select a sandwich on wheat bread with ham or any cheese. Let's see. Wheat bread, ham, any cheese. 1/2 times 1/3 times 4/4. Any cheese, 4 of the 4 selections, right? I want to go back and look at that one sandwich. 6 American cheese, 2 of 2 of the wheat or white bread. Doesn't matter which one. So we're going to say 2 of the 2 selections can be chosen. Of the meat, 3 of the 3 selections can be chosen. And then of the cheese, only 1 of the 4. So 2 times 3 times 1 is 6. And we multiply through the denominator. The denominator is 2 times 3 times 4, which is 24. Did the same thing here. Notice we multiplied straight through. What's the probability you'll select a sandwich on white bread that is either beef or turkey and has provolone cheese? In other words, we're going to select a one that does not have the other selection, ham. So, and only provolone. So white bread, there's only one of the 2. There's white or wheat. So it's one of the 2. We chose white. Beef or turkey, not ham, is 2 of 3. And then provolone is 1 of the 4. So 1 times 2 times 1 is 2 out of 24. Or we have 1 in 24, or 8.3%. Notice that I leave it in this section here, and I leave both percentages and the fraction in there, because the answers can come either way. You need to be able to go in between fractions and percentages. So what is the probability to select a sandwich with neither beef nor Munster cheese? Well, neither beef is 2 out of 3, right? Because there's 2 meats. That's ham or chicken. So neither beef means there's 2 out of the 3. Either bread doesn't matter, so it's 2 out of the 2. And then Munster cheese is 1 out of 4. So 2 breads, 2 cheeses, and only 1 seasoning thing. I don't know where that came from, but okay. So what is the probability to select sandwich neither beef nor Munster cheese? We already got through that. Neither beef, 2 out of 2 for bread, 2 out of 3 for meat, and 1 out of 4 for cheese. So 2 times 2 is 4 times 1 is 4, 4 out of 24. And there you go. No beef eliminates 4 sandwiches made with white bread. How did I get the wrong answer? What is the probability to select a sandwich neither beef nor Munster cheese? Oh, okay. I put 1 of 4 for Munster cheese. It's 3 of 4 because it's the other 3. American, provolone, and whatever the other one was. I think it's, I don't know. Probability selected neither beef. That means 2 of 3. And nor Munster, 3 of 4. And then 2 of 2 for the bread. So 2 times 2 times 3. 2 times 2 times 3 is 12. 12 of 24 is 1/2. All right. President of the high school band, Katrina needs to pick a committee of 2 to accompany her each time she visits middle schools. The director told her that each committee has to consist of 1 boy and 1 girl. 5 boys and 4 girls volunteer to go. To be fair, Katrina makes a spinner with the boy's name and a spinner with the girls' names. Each time she schedules a visit, Katrina spins each spinner once to determine who goes with her. If the spinner lands on a line, she spins again. Okay, notice in these spinner sections that all the sections are even. They have the same area inside them, whether there's 4 girls or there's 5 guys. It is separated evenly. Otherwise, it wouldn't be fair, would it? Let's draw a trigram to show all the possible combinations of volunteers who might go with Katrina. How many outcomes are in the sample space? Sample space is the total opportunities that people can go. How many different selections can we take? All right, set of all possible outcomes or results of that experiment. So Nathan can take any of the girls. Zeno can take any of the girls. Xavier can take any of the girls. Spence can take any of the girls. Or Will can take any of the girls. So there's 5 selections of guys, and there's 4 selections of girls. So 20 total outcomes. 5 times 4 is 20 total outcomes. Are all the outcomes equally likely? And what would make the outcomes not equally likely? They are equally likely. If the spaces on the spinners were not the same size, then some of the boys and girls might have a less likelihood of being chosen. All right, what is the probability that Nathan will be selected? Explain your reasoning and list the possible outcomes for 2-person committees that include Nathan. Well, it's easy to see that Nathan is 1 of 5, okay? Or 20%. We say 4 of 20 because it's 1 of 5 times 4. 1 times 4 over 4 times 5, which is 20. So 1 of 5. There are 5 boys total, and Nathan is 1 of the 5. Nathan goes if any girl is selected, so he is 1 of 5 boys, and that is his probability. If Ivy decides she can't go on a visit, she's scheduled for. How does this change the probability for other boys and other girls to be selected? We have to explain the reasoning. The boys are unaffected because we're talking about taking a girl away, not a boy. So the boys are unaffected. Still going to have a 1/5 chance for any boy. So the remaining girls, since they have reduced by 1 total girl, they have improved to a 1/3 likelihood for each one instead of just a 1/4. So this is how I feel about my 1 Powerball ticket, 1 in 175 million. So you're saying there's a chance. Anyway, y'all be blessed. Be a blessing. Don't forget to do the homework in the Google Classroom. Have a great day.